Good morning and good afternoon. Thank you for taking some time to meet with me today. My name is Eric Fishman. I'm the Vice President of Operations and Applications for Safer Systems, and I appreciate you joining me for the webinar. Today we'll be talking about live versus static data and how that one word can make all the difference in emergency response. So I guess the question is, how important can live weather and gas sensor data really be? And is it all that different from static data? So today, here with me today in this webinar, I'm going to talk about the topic and why the answer is absolutely yes. Live data is more important than static data. So in order to do that, we're going to talk about these 5 things. What's the difference between them? What are each type used for? Why does it matter, and what does it all mean? So tying it all together, and then we will take some time to field some questions. Feel free to type questions into the prompt within the console of the GoToWebinar. We will get to some of those questions. Probably won't have time for all of them, but we'll address that at the end. Okay, so now let's talk about what's the difference. The real difference between static data and live data, whether you're talking about weather data or gas detector data in emergency response, or really anything for that matter, is you're really only getting part of the picture with static data. So we have a rather drastic illustration of that here, where on the bottom right image you can see, part of the significantly larger picture, where if you're only getting one part of it, this static information or data set, you're not getting the larger picture, which is this gigantic funnel. So you can see the difference between the two can be quite drastic. And so there's a lot of challenges associated with responding to an emergency, and I'm going to talk about the difference between 2 types of data and how that plays out. So specifically for weather data, static data, you can get it from any number of places, and I'm sure many of you on a daily basis will check the weather in the morning or afternoon or at night. Again, just a static or an instance in time where you're checking the conditions for a specific purpose. The challenge here, especially in an emergency, you don't really know the quality of the data. It's not as important necessarily if you're deciding whether or not you need to put on a sweater in the morning to go outside, but you can imagine that when you're dealing with life safety critical decisions, it's important to know the quality of the data. So where is the weather data being taken in relationship to the incident? So the static data set could be 5 or 6 miles away from the incident, and the data or the actual weather data at your facility or at the incident scene can be drastically different, and therefore the data that you have is actually irrelevant and could lead to actually some mistakes. So you don't know how long ago the data was taken. You may have scoured or looked at the website at 11:55 p.m. or a.m. as an example, but the data was taken a half hour ago. And obviously microclimate changes are rapid in an incident or in any small environment. So the difference between a time-based snapshot can be significantly different. And then most importantly, that the static data can only provide a data snapshot for one instance in time. And so if you're using live weather data or something that's continuously monitored, you're going to be looking at how weather conditions change at a facility or at an incident location from time 0 as the incident unfolds. You're looking at real data. So there's a significant difference. So for gas detection data, again, static data is obtained through various measurement techniques, things that provide static data like a pull tube where you're not continuously monitoring but just taking a sample, or a gas chromatograph, or any online analyzer that's taking samples every X time period. So the data is static because you obtain the data as requested, and really we're serving here with online gas detection or continuous gas detection to be able to provide a better picture or the full picture of what's happening over an instance or a period of time. So then becomes the question of what are they used for? And both live and static data, weather data I should specifically point out, can be used for the same fundamental purpose, and that is to provide a plume dispersion model to determine the impact of a chemical release. So whether it's static or live data, both can do the same thing. The difference is we believe that live data, when compared to static data, really actually helps to start filling the knowledge gap. And what I mean by the knowledge gap is, when you arrive at an incident or you're responding to an incident, there's a lot of information that needs to be brought to the decision-making team, whether it's the incident commander, whether it's an individual responder. You've got a lot of information you need, and live data provides the best view, the information, data, knowledge to make the best decisions. So what are they used for? So you can fill the knowledge gap of what's happening, where is it coming from, so where's the release source, where is it headed, what areas are being impacted, are any critical assets or receptors being impacted, and how badly, how big is it, how long will it last? Again, these are questions that if you can respond using live data in real time, knowing this information and be able to visualize this information, you have a better chance of making more accurate decisions. So knowing the difference between the two, you can imagine that answering these questions would be significantly different if you compare the live data to static data. So when you're using static weather data, a dispersion model may be run using one snapshot of weather data. So in this case, you have wind out of the south and it's moving at 2 meters per second. You're going to project that plume profile using that data. So the data can be used in risk management planning, emergency response planning, or really even in other hypothetical situations where you want to know what might happen given these conditions or what could happen. But the reality is that it's entirely inadequate to use that static data for emergency response. Using live data from a localized weather source, so whether it be on your plant site if you're a plant guy, or if it's at an incident scene if you're an emergency responder or a first responder, the live data from the localized weather source is going to greatly improve the accuracy of the model because it updates the model output and the impact projections as conditions change. So that wind out of the south for 2 meters per second, that may have been the condition when it first happened, but after 10 minutes the wind may have shifted. And using live data from a local weather source is going to project the impacts as the conditions are changing. And that gives responders a chance to react and respond to real information and to a real situation. So the other thing that's really important is gas sensor data. When you compare it to the static type of gas sensor data, where you can really do some air sampling and validate the projections of impact or provide snapshots of the impact of an event. So I can take my pull tube out into a potentially impacted area and I can pull a sample and validate whether or not there is gas in the air or not. But when conditions change, that static data becomes immediately obsolete, and then I've got to adjust and find out where I'm going to take the next sample, where the impact is going, what's happening. And so when you're using live gas sensor data, you can continuously monitor personnel in hazardous environments, fence lines, other perimeters, like work sites or job sites, and critical receptors for impact like schools, hospitals, muster points, evacuation areas. And so by doing that, you're changing the paradigm of the monitoring so that you're getting constant feedback loop from the incident and from the plume and feeding it back into incident command to get a full operating picture of what's actually happening. And when you take this one step further, you can actually use the live data in the dispersion model to calculate the size of a release, changing the model from an estimate to a live measurement. And so when we really look at what they're used for, let's talk about the live data and understanding what's happening, right? So using real-time weather and sensor data to start understanding in real time what's happening downwind. Where is it coming from? Using weather data projections to find out where it's coming from, where is it headed, what areas are being impacted, deploying sensors or personnel to critical assets or receptors. You can understand how badly they're being impacted. So again, we start to get a full picture of what's happening based on having this live data available to us. So then the question becomes why it matters. Well, a couple famous people named W. Edwards Deming and Peter Drucker, a couple business guys, had some words of wisdom, and it says, you can't manage what you don't measure. And I thought that this was a really important thing to talk about, because when we look at emergency response, when we look at this topic of responding to a chemical accident or emergency, management of that incident is of the most critical importance. And I also heard someone say once that if you don't manage an incident, the incident will manage you. And it's really important to give yourself the best data, the best measurements to help you manage the incident and manage resources and risk and response. And in simple relationships, data leads to information, and information leads to knowledge, and knowledge leads to better decision making. And so why does that matter? It's that when you're in an incident and you're scaling up, the why it matters is the decisions that you have to make. And the decisions that we're specifically talking about here is, where do we stage our resources? Okay, so I arrive at an incident scene, I need to be able to keep my resources either upwind or crosswind of the hot zone or the downwind impact area to make sure that my people are safe, our people are safe. And who do we notify, right? Who exactly is downwind, and what jurisdiction do they fall in, and how do we notify people? Who do we warn? Whether they're schools, hospitals, assisted care centers, other critical receptors downwind. Are there large shopping centers? Is there a football game going on and the stadium's being impacted? Those kinds of things. Which gates need to be closed? Okay, I've got a plant and I've got 4 entrances and exits to that facility. How do we evacuate that facility? Which areas need to be evacuated? So whether it's a plant site, a building, a shopping mall, like I said, where are we going to do evacuation? And on the other side, where are we going to do shelter in place? Where would it be safe for people to be indoors? And what roads are we going to close to keep people from driving through a plume? How do we prioritize actions with limited resources? Now, this is a huge question, obviously, because in an incident, before we really scale up, the thing we don't have is time and people. And so having real-time data can help us prioritize our actions to make sure that we are putting people in the right places and not wasting time in areas that aren't being impacted or were impacted using, looking at a static data case. And then also, when is it safe to return or resume work, using live data, live gas sensor data to measure the ambient air, understanding when it might be safe to come back to work, which is both a time as a safety concern, right, to make sure that the areas are clear, but it's also a time and money saver potentially for a plant, understanding how long a chemical concentration may persist in the atmosphere, and then on the same line, how much money is that actually going to be saving us? So I want you guys to kind of look at these questions, these I have on the slide right here. And when I go to the next slide, we're going to show you a little video, which I'll talk through. But think about these questions, specifically the decisions that need to be made in an incident response or a chemical emergency, that are going to be made easier or at least improved by having live data, gas sensor and weather data. Okay, so here we have a video. I'll let it play through once, and then in the next round I'll stop it. The one on the left is a static data model that just shows one instance in time and how a plume might be projected downwind. And the one on the right shows real-time conditions for the same incident. And it projects the wind shifts, winds out of the southwest. That's going to greatly change the overall picture of the incident. So now running through it again, I'm going to stop it. And you'll see at about 15 minutes into the release, the time base on the bottom is 15 minutes. Using the same exact incident, on the left we have a static data model, static weather data being projected downwind, out of the south. And on the right we have the same thing, but at 15 minutes there's a wind shift. And the wind shifts from south to about south-southwest. And using the live data, we can see already the difference between the two events. And notice that on the right, we're going to already see a difference in the impacted area from the static data model to the live data model. Now, using this live data to feed the actual model and to project real-time conditions, giving real-time information to key decision makers, is going to allow you to adjust in real time. So I'm going to play this back, and then at the end I'm going to pause it. I want to talk about the decision-making process that we talked about in the last slide, and how we have to make life safety and critical decisions in the event of an actual emergency. And you making those decisions is going to be made drastically easier by having this real-time information. And further, when we look at the whole picture, having the live data fed into our model is going to be providing us, the best information in all phases of a response team. So you talk about, in the upfront case of training and drills, which is, a keystone to competent emergency response. You have to drill, because the things that you're faced with in an emergency need to become second nature, so that you can react and respond. So if you're training and doing drills with live gas sensor and live weather data, you're actually able to hone in on the skills of reacting to real-time data, and using that information in an actual emergency becomes that much easier, and then you become ready to react and respond to changing conditions. And then, obviously the actual emergency response and management, where you're actually using the data in real-world situations. So in situ emergency response, some people might call it, where you're actually on scene responding, and we've talked about that in great detail. And then lastly, in the post-event debriefing and litigation, where you're able to take that live data, you have it stored, you've got the plume dispersion model using the live conditions, and you have that stored, and all of that archive historical data is available to you, so that when the incident's over, you can sit down with your management team, with the fellow responders, and debrief on the decisions that were made and how the incident actually played out, and were there decisions that could have been made better, and then use that information to hone your skills and do better the next time. And that's really a huge part of using the live data, is it's telling a real story of what actually happened, and using that to make yourselves better, to serve and protect better both your assets and your community. And then also there's a litigative aspect to this as well, where having a real-time weather station and having data measured on site can help protect yourselves, whether you're a plant or a responder, in litigation cases, to make sure that you show the reactions that were made, the decisions that were made based on the information you had at the time, and using that to defend yourself. Okay, so in terms of the content, that's the gist of it. And at this time, I was going to open it up to questions to the audience. And we do have quite a few, so we'll get to the ones that we can here. And the rest of those, I think, we'll be able to respond to after the fact. So the first question I have is, don't I get the same information by taking gas sensor readings and refreshing weather data every 10 minutes? Thanks for the question. That's a great question. Well, the short answer is no. And longer answer is, you're refreshing weather data every 10 minutes. That may seem like a decent period of time to obtain the data, but in reality, what's happening in a course of 10 minutes is a large amount of variation in weather data. So you may have, within a 10-minute period, you may have 30 or 40 degree wind shifts, and using instantaneous data every 5, 10, or 15 seconds and allowing the complex data processing engines to handle those and create averages allows you to actually project downwind impacts using real-time data that is much more accurate than if you took a snapshot every 5 or 10 minutes. And so, the other advantage here is live data can actually be processed and used by the model without intervention. So if you have a static data, you'd have to be plugging it into a model, when you're getting the data, and then rerunning that model, and then still getting a static plume. Whereas if you're using live data, you can process that data and use it by the model without intervention. So it's really quite advantageous to do it that way. A second question we have, and again, thank you all for your questions. I really do appreciate it. The video shows very different results. Is that video an illustration or is that a real model? That actually is a real model, and it's our model. And we actually just used our same modeling engine. On the left, we just plugged in a static weather condition, and on the right, we used the same starting condition and then used some live historical data for a specific region to project the plume. And you can see it's the exact same model using the exact same inputs, so same chemical, same release rate, same location, but just changed the weather data that was used, and you can see the drastic difference in the model. Another question about live data. How do I get live data and use it for dispersion modeling in an event? That's a good question. So, typically when we think of live data, whether it be gas sensor or weather data, we're talking about continuously online data sources. So, you can get them from any number of manufacturers or vendors, or through us. You can get them from a lot of the preferred gas vendors that you find out there: your Ray Systems, Honeywell, Draeger, Gastronics, MSA. All of those manufacturers, provide gas detection, and further weather stations like Campbell or Coastal Environmental Systems, AirMar is one, provide actual real-time data sources, and you can use that data. That data can be used through some data communication methodologies, and we specialize in building custom data communication solutions to fit our customers' needs, but using the data communication, feed them back to a computer that's running the model, and then it will come into the model in real time. Another question. This is a great question. I already have a bunch of gas detection equipment and a weather station at my plant. Can I use those to get live data for a dispersion model? And I can't say categorically yes, because there are exceptions to every rule. But for the most part, at least for safer systems, we can use almost any data source for gas detection or weather data and plug it into the model. Even if we can't directly interface to the device, we could interface through an existing control system or some back-end customized software that can be built. There's lots of different ways. Now, SAFER does have, we do have specifically a lot of data communication drivers and technology that allows us to communicate with directly to a lot of our preferred manufacturers and vendors. And then there are also standard industry protocols like OPC, like PI, Modbus interface, and any one of those can be used to get the live data into our specific dispersion model. So the answer is yes, and obviously the most important thing here is that we help you maximize the return on the investment that you've already made. So another question is here, this one about Aloha. Okay, I'm currently using Aloha. Where does that fall into this discussion? So this is great, and I think actually we have a webinar coming up related to Aloha, but Aloha is a great application for what it's designed for, and it definitely has its place. But Aloha would fit into the static modeling discussion, and it's more of a brute force modeling engine that allows you to calculate and project where things are going based on the conditions right now. And you can plug in conditions, even if they're real time at the time of the incident, based on the discussion that we've already had today, that the conditions are going to change. And so Aloha would fall into a static modeling tool. And again, while we find it to be a very useful tool and very widely used tool, I might add, its ability to be used in emergency response is diminished by its static modeling nature. Another question about measurement equipment. So are some measurement equipment preferred over others? And the answer to that is yes. Obviously, it depends on the needs of a specific facility, but you have to take into account some of the various specifications that are out there and what's important to you. And so As an example, gas sensor manufacturers all have different specifications and obviously different applications. And so you may have a continuous online gas monitor that has a temperature operating range that's different. So one may go down to -50, one may only go down to -20. And if you, depending on your environment, if you were living in northern Alberta or Edmonton or Fort McMurray, your operating requirements are going to be a lot different than somebody in Houston or Baton Rouge, because the temperature extremes are significantly different. Another thing about gas detection equipment is what's called T90 response time. So, the time that it takes for a sensor to respond to 90% of its range. And that is a really important specification or metric in gas detection technology. And, the better you can do in that specification, obviously the more accurate the data you're going to feed to the model is, which means the more accurate the model is going to become, giving you better information to make better decisions. So again, it's all about the application and the need and ensuring you're providing the best data. And then there's also different types of equipment. And for gas detection, there's point detection devices that are going to detect a single point in space along maybe a perimeter or just a specific point. You can move the device maybe from point to point. And there's also the open path type of technology that can measure a span or a length. And depending on the application, if you're you're looking at really monitoring an entire fence line or perimeter, you may choose an open path detection scheme over a point detection scheme. And then looking at weather station granularity is really important too. So there are a lot of devices out there that will only measure wind direction increments over a 25 or 30 degree resolution. And that's really not good enough when you're looking at continuously monitoring an incident scene where the difference between 0 degrees and 25 degrees could mean completely different impact areas. And we want to point that out as something that's very important. And then you have differences between mechanical weather stations and ultrasonic weather stations, and the differences in the quality of the data that you're getting there. Okay, so that looks like that is going to be all for the questions. I do want to thank you all for joining me today. We'll be posting a video on our website, and we'll email you guys, all the participants here today, a link so you can forward it on to others or watch it again later. And we're also going to follow up by email addressing any questions we weren't able to get at directly today. And again, thank you all for your questions and your continued participation. I appreciate the level of engagement. It was obviously all my pleasure to be your host for the day, and I wish you guys a safe and happy day.